Thank you. So yeah, I'm here to talk a little bit today about the state of WebRTC. So just before I actually start doing that, can I just have a show of hands who's used WebRTC? Okay, that's about expected. It's barely anyone. Who's heard of WebRTC? Even better. That's good. Okay, cool. Just a good sort of coverage. Just a little bit about me. My name's Rob Hawks. I'm a digital tinkerer is the best way I can describe what I do. I basically play with new technologies and push them to the limits and sort of just see what I can make them do. I'm a former technical evangelist for Mozilla. So I was working on things like HTML5 games, Firefox OS, and sort of general web technologies. An author of a couple of books, such as Foundation HTML5 Canvas, and co-author of a HTML5 gaming book, and currently taking some time out from sort of a day job to work on a few personal projects, such as things like Busy Cities, which is an experimental sort of WebGL project, bringing in like open data like buildings and census data and, I don't know, crime data and stuff like that, and overlaying it in 3D in the browser and making it like SimCity, but for real cities. So that's what I do in sort of my spare time. But I'm here today to talk to you about WebRTC. And what is WebRTC? Well, the most basic description is it's a peer-to-peer communication technology for the browser, but there's a lot more to it than that. The sort of official description is a free sort of open project that enables web browsers with real-time communications capabilities via simple JavaScript APIs. It's a bit of a mouthful. I like to describe it as sort of WebRTC is Skype in the browser, sort of. There's a lot more to it than that. WebRTC is a W3C specification. It's supported by Google, Mozilla, Opera, amongst many other people. It's currently in the editorial process, and it's not yet a full recommendation. So it's still in a state of flux. Things are still changing all the time. But the spec is a fantastic resource if you want to get sort of in-depth technical information about what's going on behind the scenes, how it should be implemented. It's less about telling you how to use the APIs and more about how they should be structured from a browser point of view. The unofficial WebRTC site is much more useful from the API point of view. So this is a fantastic point of view for getting sort of higher level information about how to use it, the codecs involved, browser implementation status, and things like that. And the FAQ here on this site is actually a really good way to get to grips with that. So we already have real-time communication technologies in the browser today. We already have technologies such as WebSockets. So why should we be using WebRTC? At the most basic level, WebRTC and WebSockets both achieve completely different goals. WebSockets is purely about providing sort of reliable, real-time data connections in JavaScript. And WebRTC, on the other hand, is about providing a network infrastructure for real-time streaming media. So it's much more sort of media-focused, at least that's how it's advertised. And these communication methods, such as WebSockets, require a server to act as a middleman, sort of passing messages between the people connecting via that technology. And the problem with this middleman approach is that you have to wait for the message to reach the server and then be passed on to whoever it's sort of destined to, and then be passed back to the server and then again back onto you. So it takes quite a while. And if both users, both endpoints, had a latency to the server of 20 milliseconds, which is incredibly sort of conservative, a round trip between the two users would take 80 milliseconds, which is a huge amount of time. That's nearly 1/10 of a second just to send a little message back and forth. On the other hand, WebRTC is peer-to-peer. So it's there's no middleman because it's just directly connecting two browsers together without a server in the middle. So this means you can send messages directly between those two users without having to worry about that server at all. And if the latency was the same between these two users, so 20 milliseconds, a message or a round trip would take just 40 milliseconds, which is half the time. Now this is assuming a lot of things, but this is kind of roughly what you can expect. Another big draw to WebRTC is that it's primarily using UDP. which is a method of sending data across the network in an unreliable fashion. In comparison, technologies such as WebSockets, HTTP, etc., use TCP, which is a reliable method of sending data. Now, without going into too much detail, UDP is a lot faster than TCP because it doesn't worry about sort of order and error correction and all of those sort of important things. And because of this, you wouldn't want to use UDP to send important data that needs to be received in order and whole, so things like websites. Instead, UDP is commonly used in situations where you only care about the most recent, the most latest update. And you don't have to worry about sort of receiving all of the old ones that were sent in the past and might possibly be lost. So things like streaming media, online games, that kind of stuff, it's very, very common in those situations. And WebRTC is the first time UDP has been available in the browser using JavaScript. So it's actually a really exciting time because usually you would have to have used plugins to do this, and now you can just do it with APIs that have been baked right in. And I'm personally incredibly excited about playing with this because there's so much more to it than just video communication, and I'll touch on this in a moment. So the ability to connect peer-to-peer with another browser certainly sounds cool, but what exactly can you do with it? So like I was just saying, sort of the most common approach is to use video and audio communication, so the whole Skype in the browser thing. This is the approach that most people are sort of hearing about WebRTC. It's the approach that most people are taking when they're playing with WebRTC, and you can't blame them because that's kind of what it was built for. And most demos you see will be using this kind of approach. But there's a lot more to it than that. There's also screen sharing. So there's an example in Chrome, actually, which I'll sort of show briefly at the end, which allows you to share the browser window that you're currently using using WebRTC. So it's kind of similar to the video and audio approach, but also slightly different. Then there's collaborative activities, so things like collaborative writing, collaborative coding. This is another area which is gaining a lot of interest because this idea of real-time collaborative activities is something that's happening quite a lot at the moment, like Google Wave and Google Docs and that kind of stuff. And then there's multiplayer games. So this is an area that's going to have a huge benefit from WebRTC, mainly because of the UDP sort of networking that I was talking about. Having that unreliable network connection is going to sort of vastly improve the network speed that these games can run at and the kind of things that they can do in multiplayer. So there's going to sort of be a new breed of web games that are going to come about because of this, and we're kind of seeing this at the moment. I'll show you a demo sort of shortly. But there's a lot more to it than that. There's not just the ability to just connect two computers together. That you could actually connect, say, for example, in theory, multiple users to a server using WebRTC to just benefit from that UDP connection. Now, that's not really how WebRTC was built to be used, but you can definitely do things like that in the future. Now, another use case is P2P file sharing, so sort of BitTorrent in the browser. That's something that's gaining a lot of interest because of these this UDP network connection. And just imagine the ability to not have to use a server to quickly send a file to another user, one of your friends, in another browser in a completely different location. You can do that now without having to worry about that server and sending it at as fast a speed as you can. And something I hadn't heard about until recently was the idea of using sort of WebRTC to be a peer-to-peer CDN. So using website visitors to distribute asset serving, sort of instead of downloading those from servers, you can have the first user who downloaded an image actually sort of share that out amongst other people who have just started visiting the site after them. And the more visitors you have, the more those assets can be shared amongst each other. There's a couple of projects using this, and I'll detail those in a moment as well. And related to multiplayer gaming, there's the idea of using WebRTC to connect devices in a remote way. So this kind of flips the way you think about WebRTC at the moment, in that you can actually, instead of connecting to another user in another location, you connect two devices in proximity together. So for example, I could connect my phone to my laptop and use my phone as a controller for a game that's playing on my computer. For example, you could make the phone look like a SNES controller or something, and it's playing Mario on here. That's the kind of thing you could do with WebRTC because you've got serverless communication. It would run across the local network and it would be incredibly fast. So actually using WebRTC, there's 3 main APIs. Let's quickly take a look at each of them. So you've got the MEDIASTREAM API, which most of you have probably heard of in its other terminology, which is Get User Media. Get User Media is a part of the MEDIASTREAM API. And this API gives you access to media streams, such as webcams and microphone input and that kind of stuff. Now, Get User Media isn't WebRTC support. You kind of see this in a few places where people will say, we support WebRTC, and it's not. They actually just support access to a webcam. It is part of WebRTC, but it's not WebRTC as a whole. And it allows you to do quite interesting stuff. So you can pull down the webcam input, you can pass it off to a canvas element, get the pixel data, and then you can start manipulating it. So this is a demo that someone made by converting the webcam input into ASCII characters, just for fun, why not? But you can do that now. You can connect to devices using JavaScript and then do something with that input, again, using JavaScript. It's really cool. There's also the peer connection API. So this is kind of the bread and butter of the WebRTC APIs. And this allows you to make those peer-to-peer connections between 2 browsers. You can then attach media streams like video and audio to that peer-to-peer connection. The last major one is the data channel API. So whereas the peer connection API is more worried with streaming media, the data channel API is specifically built to allow you to transmit arbitrary data connections or data messages using UDP. So this is very, very interesting. You don't have to connect a media stream to this. So the desktop support for WebRTC is actually pretty good. It's got a lot better in the last few months. Firefox supports WebRTC by default in version 22, which is currently going through the testing stages in the sort of beta, Aurora, and nightly branches. If all goes well, WebRTC support is sort of slated to land sort of end of June sometime. Now, obviously, things are in a state of flux and things might change, but that would be a public release of it sort of turned on by default. You can play with this in the development builds today if you really wanted to. The current release of Chrome already has basic support for video and audio WebRTC in the public version enabled by default. If you want to use the data channel, you have to use Chrome Beta for the moment, and at the moment that's behind a flag. In Canary, at least, that has been enabled by default, so you can start working with that again today. Opera at the moment only supports the ability to get audio and video using Get User Media. That might change now they're starting to support Blink, and as they sort of start adopting things from Chrome, then we'll see how that progresses in the future. IE has no WebRTC support at all. Kind of not a massive surprise. But if you use Chrome Frame, you can get WebRTC support. You gotta love Chrome Frame. It's worth mentioning. Mobile support is a very interesting one. So this is where things do become very interesting. The ability to communicate between desktop and mobile devices with peer-to-peer technologies is kind of cool. Now, Firefox and Android has WebRTC support. It's currently behind a config flag. It's very early days and your mileage may vary. Like I said, things are in a state of flux, but you can use this today and it does sort of work if you know what you're doing. Now, I know Mozilla sort of plan to ramp up mobile WebRTC implementations in sort of the coming months. So sort of keep an eye on that and you can sort of rely on it coming at some point in the future. Chrome on Android already has WebRTC. This is behind a config flag as well. It seems to be quite reliable, and you can certainly use it for demos and stuff today. Things may change again, but sort of you can test it and use it. Opera Mobile only has support for Get User Media, so just webcam and audio. So this isn't really WebRTC support. I know BlackBerry has support for Get User Media as well. I'm not too sure about the other mobile browsers. Now, interoperability is a big question because you don't want to have a technology that you can only use between sort of one browser vendor. That kind of defies the whole point of web technologies. So the situation wasn't very good with WebRTC until quite recently. Fortunately, the things have changed. Chrome and Firefox did a joint announcement in the last couple of months that actually sort of told the world that they'd been working together on their WebRTC implementation and that they can now talk to each other, the two browsers. So you can make a call from Firefox and you can answer that in Chrome, which is very, very cool, and it's big news. And it was also a good example of how the browsers do and can work together. There is this sort of misconception that there's these browser wars and Chrome guys hate the Firefox guys and who hate the IE guys and everyone hates the Apple guys and all that kind of stuff. And I mean, I've obviously been working in Mozilla, or had done for the last 2 years at least, and that isn't the case. Like, we are kind of friendly and we do work together where we can. So it was nice to see this happen in public, and it did come off quite well, and it was just, I don't know, kind of nice and fluffy to see it all come together and everyone was kind of pleased with it. So yeah, so let's show you a quick WebRTC demo. Hopefully this is going to work. Just a simple one. So what I'm going to do is use a demo that someone else has created. All the links are in the slides, which I'm going to put online. I'll give you the link to that at the end of the talk. So with this, we're just using this demo, and what we're going to do is just jump into a chat room. So we'll start this, and what I need to do is just allow. So when you use the webcam, it asks you for permissions because you don't want it just to turn on automatically because that'd be kind of creepy. So you can see the back of my head over there. What I'm going to do is jump into Firefox and jump into the same chat room. Enable the devices. And there you go. So the two browsers are talking to each other. They used a server at one point, and I'll describe how they used that. But right now, they're not actually using a server. They're connected peer-to-peer. Now, obviously, it's all on my computer, so it's going to be incredibly fast, and it's not really using a network connection. But the technology still applies, and the way this is implemented is exactly how you would do it on a standard implementation for a web app that was communicating someone from Australia and the UK. It's exactly the same concept. And it's pretty cool. So let's jump back into the tool. Let's turn that off first, because I don't want to see my face. Okay. So you've seen how WebRTC works. You've seen a demo of it. So let's have a look at how to actually use it. The most basic API to look at first is the MEDIASTREAM API, so getting the webcam input. In this example, we have a very, very basic demo that actually does access the webcam. Just like you saw in the WebRTC demo before, when I first sort of clicked allow and my face popped up in the top right-hand corner, this is kind of what this would do. The only thing you would need, aside from this little bit of JavaScript, is a HTML video element to attach that webcam stream to. And it's also worth pointing out that although you can't see it, at least in this JavaScript code, I'm using a very basic polyfill just to abstract away the vendor prefixes. But the API calls and the methods are exactly the same as they would be. And again, like all the code and the links and stuff are in the slides. It's also worth mentioning that if you want to use this technology, you should do it via a domain, because you'll run into security restrictions otherwise, just because you don't want a random file running your webcam when you don't really want it to happen. The more interesting API is the PEERCONNECTION API. So let's have a look at that one. What we're going to do is take a quick look at one that's just running all in the same browser page, so we don't have to worry about what's called discovery, which is connecting two users together. We're just going to assume we've done that already, and we're just going to make a WebRTC connection. So in this example, we're going to use the polyfill, just to avoid that browser prefix dance. And what we're going to do is also sort of avoid the HTML. Again, it's just a couple of video elements to attach streams to. The first step we're going to do is call the getUserMedia method and start setting up the webcam. And what we're going to do is connect the stream from that to the HTML video element, just so you can sort of see a local view of what your face looks like if you forgot. Next, we're going to store a reference to the stream that you've just taken, so we can use that later on as we start connecting users up and doing sort of cool stuff with it. So at this point, we haven't really achieved anything apart from seeing your face in the top right-hand corner. The next step is actually sort of setting up that peer-to-peer connection. So what we're doing here is, I'm not going to run through it line by line, but what we're going to do is basically set up the two peer connections. So one local, so just one computer, and one remote, which would be another computer. Like I said, in this case, they're all on the same computer. So PC1 and PC2 are the two peer connections that we're going to set up using the RTC peer connection method. What we're passing there is an options sort of object, which at the moment is null, but what it could be is what are called turn and stun servers. Now, you don't need to worry about this now, but when you have to start breaking through firewalls to make connections, you can use that options object to provide servers to help sort of get around that. Once we've done that, we're going to set up a couple of event handlers for what's called the on-ice candidate event. I'll sort of touch on that in a moment. Basically, what this does is it allows the browser to work out how best to make a connection between two people. And then from there, what we're going to do is set up an on-add stream handler for the remote peer, and this just worries about when someone actually starts connecting and starts doing something with that. We're then going to set up an add stream handler. So this actually sort of works out sort of what to do when a stream has been added to the connection, so MEDIASTREAM. And then what we're going to do is call something called create offer. So what this does is starts off a process that connects two users together. And you have an offer and an answer. So the first step we're doing is this offer, and what it's going to give us is something called a session description. Now, this session description is a huge, huge file, which I've cropped here just because it would bore you to death. And it's basically a description that allows the browser to know how to make a connection between two users and what kind of media it wants to share. So whether that's webcam, whether that's microphone, or whether that's something new that we haven't even worked out yet. The browsers pass this amongst each other, and then they work out what to do from there. Going back a step, we had that ICE handler, and this is the actual handler for that. And what it does is it just basically takes these different types of IPs and connections that a browser could make to connect these two peers together and passes them to the other peer. So whatever the connection types were for the first local peer, they get sent and stored on the remote peer, and the remote ones get sent and stored on the local peer. From there, they can kind of work out, right, which ones work best and how can we make this connection without sort of going sort of the long way around. That's all you really need to understand about that. It's using a technology called ICE, and if you want to really get into the nitty-gritty, I'd sort of look into it. If you don't need to do that, don't worry about it, because it will just work. So the last chunk of code is actually going to start setting things up, because we haven't quite got there yet. So we're just going to tie up the loose ends. So what we're doing is jumping into the handler for the create offer event, or method, and we're going to take that description that we were given, that sort of description of connection types and what have you, and we're going to set that on both the local and the remote peers. What we're then going to do is use the remote peer and create the answer. So we've taken the offer, we've done some stuff with it, and now we're going to say, right, here's the answer, and here's how we're going to make the connection. And all we're doing there is just basically taking another session description, but this time for the remote peer. And what we need to do is use the other handler to save that and sort of store that on the local peer. From there, we actually have a connection. Now, it might not seem like it, but we do have that. There's other event handlers to sort of deal with when a connection is actually sort of sparked into life. But after that sort of offer and answer dance has been finished, you actually have a connection up and running. The last handler is just to deal with when a webcam stream has been connected to the peer, and then you can use that to spark up the new HTML video element with the remote streaming video. And at that point, you would actually have a WebRTC connection up and running. Now, the problem with that demo is obviously that it was only running in a single browser page, and they all knew about each other, and it was really easy to sort of hook everything up, and you didn't have to worry about it. Now, most of you want to use WebRTC to make connections between remote browsers, so like how people normally use the internet. A full code example about that would be a little bit out of scope for this, just because there's just so much of it, and I have linked to examples in the slides, so you can actually dig through this if you want to. Instead, what I'm going to do is sort of briefly go into the concept of signaling or discovery, which is the idea of sort of finding two people who want to connect to each other and then working out how to get them in touch and sort of take the server away and have them connected peer-to-peer. So with that local peer connection example, that act of peer discovery sort of didn't happen. So we didn't have to worry about it, and they just quickly connected peer-to-peer, and there was no server involved. With a full peer connection example, what you need to do is use that server to connect those two peers together. So what we're going to do is use a technique maybe such as having a chat room name or a unique identifier that we can give both users. So in that demo I showed you earlier, we joined a room called WebRTC. And because both users did join that room, the server knew that two users wanted to connect to this room that had the same name. Okay, they must want to talk to each other. And then from there, the server can handle those session descriptions that were created using the createOffer event and the createAnswer event method even. And it can take those and go, right, I know where to put these, because it takes one from one user and it knows it wants to connect to the other user, does a little loop, passes it over to the local user, and the same the other way around. Once they've got that information, they don't have to worry about the server, they can drop that and they make the peer connection in between. Now, it does sound a bit sort of crazy, but the concept is pretty simple. It's just the server's just acting as a proxy basically for the messages, and it just needs to know how to connect two people together. It has no sort of part in the actual WebRTC peer-to-peer connection. You could disconnect the server afterwards, and the connection would still be running. Yeah, so once that session description handshake has been made, those two peers will be connected directly. Skipped a slide here. So yeah, at this point you can disconnect that server. Actually, I just wanted to go back a step. So the common approach that people use to do this is usually with AJAX. You can also use WebSockets as well. It's a fast sort of real-time approach that you can do. So it's a nice way of combining another real-time technology to sort of benefit the newer real-time technology as well. So at this point, you kind of know how to do peer-to-peer connections with streaming media, which is kind of cool. But what if you want to do stuff with arbitrary data? So you want to do multiplayer games, or you wanted to do instant messaging, stuff like that. For that, you want to use the data channel API. Now, the cool thing about the data channel API is it sort of piggybacks on top of peer connection. So if you didn't set up a stream in the peer connection, you could use data channel API without having to have audio and video. You can also have a data channel API running on top of a peer connection with audio and video streaming as well. So in this example, what we're doing is just piggybacking off the peer connection using the create data channel method and just passing it a label and an options object. And in the options object, we're just saying we want this connection to be not reliable. This basically means UDP. In the future, you'll be able to set this as true, so you could have a reliable TCP network connection or data connection, and you could still have an unreliable media connection, all in the same WebRTC connection or API. And then what we're just doing after that is just setting up a few handlers to deal with when the connection's been made, and then dealing with the messages that are sent and received. And the messaging API is very, very similar to WebSockets. So it's just you're listening to an onMessage handler and you're sending message using a send method. It's pretty simple. So now that we've seen how WebRTC works, let's take a look at some of the projects that are using it today. Now, there's actually quite a few of them, considering it's such a new technology. One of the coolest, which happened quite recently, is Tow Truck by Mozilla. Has anyone heard of this project? Okay, not many. Okay, cool. I know you have. So yeah, Tow Truck is a project which allows collaborative browsing, basically. So what you can do is you can set up a WebRTC connection with a friend, and then you can basically follow each other around the web. It sounds kind of creepy, but you know it's happening. So you can see their mouse on your screen, and they can see your mouse on their screen. And you can chat amongst each other. You can sort of browse the page together, talk about what's going on. If I then jumped onto another page on the website, it would notify the other person that I've moved a page, and do I want to follow them around? That's the slightly creepy part, but it is kind of cool. And that's just all using WebRTC. Now, obviously, you need to be connected to the internet because you're browsing websites, but it's not using a server to make that connection. It's not using the server of the website that you're browsing to do all of that. Theoretically, that could be baked into a browser extension or into a browser itself, and you'd be able to follow people or do this on any website anywhere without them having to embed anything. There's another project called conversat.io, which is basically using WebRTC to create small, easy to set up chat rooms. So basically, all you do is you just enter a room name and just start, and that's it. And you can have up to 6 people just chatting together. Peer.js is a really interesting framework which tries to abstract some of the data channel implementation. Now, if you just wanted to use WebRTC just to send data, you maybe wanted to use it instead of what you're doing with WebSockets today, have a look at Peer.js because it's a really simple way of just implementing that and not having to worry about all of that discovery mechanisms and signaling and all the underlying networking. You just sort of use it as an API like you would with WebSockets. Another project is Twellophone, which is a Twitter-powered video and text chat application. So it uses your Twitter followers list to give you a sort of contact or an address book that you can then ring other Twitter users, and they log in using Twitter, and then it just makes the WebRTC connection for you. Kind of interesting. I've not used it myself, but it is cool that you can now do that. You can sort of connect these 2 different services together. Twilio is another service which is getting increasingly popular, which allows you to make and receive real-world phone calls via sort of code. So this includes from the browser now with WebRTC. So you can actually use JavaScript to make a phone connection to a real phone using sort of real phone numbers, and you can talk in the browser using WebRTC, and it will come out of someone's phone which is not using WebRTC. Now that kind of blew my mind when I heard about it, because the ability to ring someone with my code is weird, and the amount of stuff I could do with that is immense, but I really need to look into that because it'd be kind of creepy. Going back to the CDN examples that I was talking about earlier, PeerCDN is a project that aims to try and prove this concept. And it's offloading the serving of website assets amongst a peer-to-peer network of connected visitors. Now, they've got a really cool video. I'd advise watching it because it's a cool example of how it works and some of the implementation issues with this technology. But they don't yet have a demo. They advise you to sign up and find out more. On the other hand, PeerKit is another approach that's using peer-to-peer CDN. And they have a demo that you can use today. And if you go to the website and you load up the image, it will tell you the first time that you go on that it's been loaded by the server. And then if you load it up in multiple browser tabs or you get a friend to open it up, then actually that message will change. It will say it's been served from a peer. And what's happened is whoever connected first has basically sent that off to you rather than you getting it from the server. And the more people connected, the more people that are sharing it. So it's a really interesting way of using the technology in a way that it wasn't really built for. Now, there's actually a few use cases for this that would be kind of cool. Like, if you wanted to distribute something amongst the attendees today, and you didn't want to sort of, I don't know, kill a server, you could distribute it amongst the local network as long as one person has got that and can start streaming it out to you. Now, that's a sort of simple example, but those are the kind of things you could do with it. Banana Bread is a project by Mozilla, which was basically porting a native game over to HTML5 and JavaScript using mscripten. They recently added the ability to have multiplayer using WebRTC. So this is a quick video of the guys in Toronto, I believe, playing the game, because it's work to do that. Very cool. And yeah, this was just after they finished it, and it's kind of cool, like real-time multiplayer game using WebRTC, using JavaScript, no servers involved, peer-to-peer connections. Chrome also added the screen sharing ability. So that was something I mentioned earlier. There's a HTML5 Rocks article about how they did that and how you can implement that. I'm not going to go into detail and show you because it's like the video example, it's just sharing a whole browser tab. but it's kind of cool. There's also Phono, which is a jQuery plugin for making phone calls from the browser. Phono is also used in att.js, which is an AT&T project, which is similar to Twilio in the ability to make real phone connections using WebRTC from the browser. att.js has a little bit more than Phono because it has, I think they have a partnership with Ericsson to do a few sort of funky things. But it's worth looking into if you're interested in that. There's also OpenTalk, which is another platform. You can tell there's a sort of theme going here with platforms for video and audio. This is another platform for creating video and audio connections in the browser using WebRTC. OpenTalk's quite interesting because they're trying to look at archiving the calls as well. It's a little bit like Google Hangouts. They don't yet have that working for WebRTC, but I can't wait to see that actually happen. There are sort of recording APIs being worked on to record the audio and video from the browser. Going back to the file sharing aspect, this is an example called File Hangout, which basically allows you to use the data channel to send and receive files amongst a small sort of collection of users, peer-to-peer. So it's not technically anonymous, but you can actually log into this and have your name as anonymous, and you can just send the peers whatever you want. They have to obviously accept it, but kind of weird how you can do that. And yeah, it's just an interesting example, and again, the links are in here, so if you want to dig into the code. The cool thing about the guy who makes these is that he has a whole bunch of different examples that use different aspects of WebRTC, and he's got the code for all of them available. Something slightly different is Squiggle. Cool name. It's a collaborative dashboard for remote working, basically allowing you to spy on your colleagues all day and technically share resources and sort of share code and do instant messaging and stuff like that. I wouldn't say it's for remote working. I'd say it's more for team meetings and stuff like that. I wouldn't really want to look at my colleagues all day with a timestamp at the bottom and sort of them not knowing I'm watching them. But yeah, it's kind of cool. Probably my favorite use case of WebRTC at the moment is Ericsson Labs did a 3D WebRTC demo. So what they did is they synced up a depth sensor, so a Kinect basically, with a webcam and sent that all via WebRTC. And on the other end, they used WebGL or 3D goggles to view that person in 3D via WebRTC. Really, really cool example of different web technologies all sort of coming together and combining to result in something that we just wouldn't have been able to do months ago, let alone a few years ago. Codasium is an example of collaborative sort of activities using WebRTC. So this is effectively a code editor. They market it as for programming interviews, but I'm not sure there's that big of a market for an entire app for it. But basically, it's the ability to have two people coding at the same time using WebRTC. You've kind of already seen that with other technologies, but here's one with WebRTC. Hopefully that's a WebRTC call. Lastly, there's one called GrimeWire. So GrimeWire is something that I haven't really looked into too much yet because it's very, very new. And it's a crazy project aimed at creating an operating system with browser technologies that uses WebRTC to make connections between the various components of the operating system. Now, it'd be interesting to see how that progresses and sort of what happens and where it goes from there. But it's another cool use of WebRTC that's slightly different than what we should be expecting. So I hope I've managed to pique your interest a little bit with WebRTC. It's a really cool technology, and I do advise you experiment with it. There is so much to the technology that people just haven't really explored yet, and I'm particularly interested in seeing how people use it around mobile devices. So I'd love to see what you do with it. If you do something with WebRTC, please do ping me on Twitter, because I'd absolutely love to see it. So that was me. I'm Rob Hawks. I'm at Rob Hawks on Twitter. You can follow me on my blog if you want to sort of keep up to date with what I'm doing with my various projects. All the links are down there. Slides are on slideshare.net/RobHawks right now with all the links and everything. So if you do want to dig into WebRTC, then you can do that right now. So thank you for listening. Wow, okay. At the front. Oh, yeah, you need a microphone, sorry. I can hear you, but not everyone else.
Hi. How is the roadmap for audio and video recording?
What's the roadmap like? That's a good question. So I believe Chrome does have the ability to start doing that. I'm not sure about the other browsers yet. I know it's something people are working on, but I don't have the specific answer right now to sort of give you a firm idea of that. Yeah, definitely.
Hello. We've seen always peer-to-peer connections, and we'd like to know if the spec includes also broadcasting or multicasting connections. And the other question is if there's any server-side implementation so far.
Okay. So to answer the first question, I don't believe there's yet any ability to do things like multicast. I really do want that because that would be really, really cool. I know there's a bug on Chrome to get that, and it's got constant attention, and I'm following it daily to see if it gets added, but I haven't seen it yet. The server implementation is something I really want to see. I know a few people have been looking into it. I don't know the ins and outs of the networking to understand how close they are to it yet, or how possible it is. But from what I'm seeing, it wouldn't surprise me if something comes out in the next few months to a year. Like, it's the kind of thing that someone's just going to knock up in Node.js and everyone's going to go with it. There are sort of native plugins to use WebRTC, so I'm sure someone will just use something like that to run it via Node or something. So it should come soon.
Okay, so can you comment a bit on security, encryption and such?
Right, so security and encryption, good question. I did want to talk about this actually. As far as I'm aware, the WebRTC connections are encrypted. Security, on the other hand, and permissions is slightly more interesting. So at the moment you get permissions dialogues when a WebRTC connection is being made, so you do know, or at least when a video and audio call is being made. So you do know that it's trying to access your hardware and it's going to start looking at your face, and you should stop doing weird things and look at the camera. On mobile it's even more difficult because on desktop, at least on Macs, you have a little light that tells you that the webcam's on. On mobile, where's the light for the webcam? So how do you know when it's turned off? How do you know if, when you lock the home screen, that it's still not recording you? I believe some implementations actually still record you when it's locked. So there is a lot to be done with permissions and sort of security from that sense. I know the browsers are talking about it. It's not like they're avoiding it. It's just a lot of discussion to do that in the specifications. And it's kind of up for interpretation as well. But regarding the encryption, that's sort of all in WebRTC today.
Well, we are out of time. So
sorry.
Who gets the phone?
I think the multicasting. Yeah, that's the main thing I'm interested in. So, yeah, if you want to grab me on Twitter or grab me here, I'll be here for the next couple of days so you can talk more about WebRTC.